Hello everyone, welcome to Primema. Today we are going to discuss some important math problems on time, speed and distance based on previous year questions of SSC. We will be solving these questions using speed matrix. So let's start our session. Here, you already know this equation, distance is equal to speed into time. Whenever you get questions based on distance, speed and time, just try to find it out. Which one of these three is constant? If distance is constant, then speed is inversely proportional to time. Then use this and directly apply ratio method. When speed is constant, distance is directly proportional to time. Then use this and directly apply ratio method. When time is constant, distance is directly proportional to speed. Then use this and directly apply ratio method. So, our first question is, a train running at 7/11 of its own speed reached a place in 22 hours. How much time could be saved if the train runs at its own speed? A train runs and reaches a destination at 7/11 of its own speed, and it takes 22 hours to reach the destination. If the same train runs on its original speed and reaches a destination, how much time it could have saved? How much time it could have saved? So, here you already know, you can see distance is common in both the case. Both the case distance is same. That is, distance is constant. That means speed is inversely proportional to time. So, if you take old speed and new speed ratio, old speed is to new speed ratio. Old speed is equal to S. New speed is equal to 7/11S. That means S cancel. 11 is to 7 is the old speed is to new speed ratio. If you take time ratio, that means time is inversely proportional to speed. So, this will be 7 is to 11 because time is inversely proportional to speed. So, if speed ratio is 11 is to 7, that means here distance is constant, then time ratio will be 7 is to 11. Here, when you run at new speed, that train reaches destination at 22 hours. That means 11 parts is equal to 22. That is, this 11 is equal to 22 hours. 11 part is equal to 22 hours. That's 11 into 2 is equal to 22. Then 1 part is equal to 2 hours. That means 7 part is equal to 7 into 2. That is 14 hours. So, saved time is equal to 22 hours minus 14. That is 8 hours. So, option B is your answer. You can directly use this 7/11. Then, you know, if old speed is equal to 11, new speed will be 7. So, 11 is equal to 22 parts, 7 is equal to 14 parts. 22 minus 14 is equal to 8. You can directly apply this if you understand the logic behind this constant and ratio method. Next is question number 2. If I walk at 3 km per hour, I miss a train by 2 minutes. If, however, I walk at 4 km per hour, then I reach the station 2 minutes before the arrival of the train. How far do I walk to reach the station? So, we have to find out the distance here. If I walk at 3 km per hour, I will miss the train by 2 minutes. If I walk at 4 km per hour, I will be earlier by 2 minutes. Here, this difference between 2 minutes after and 2 minutes before is 4 minutes. Here you can see distance is common. That is, I have to reach the railway station at 3 km per hour and 4 km per hour. In both the cases, distance is common. If distance is common, take the speed and time ratio. Speed ratio is 3/4. Walking at 3 km per hour and walking at 4 km per hour. That means time ratio will be inverse of the speed ratio because distance is common. If distance is common, speed is inversely proportional to time. So inverse of 3 by 4 is equal to 4 by 3. And here difference between 4 and 3 is equal to 1 part. 4 minus 3 is 1 part. 1 part is equal to, you already know difference between 2 minutes after and 2 minutes before is 4 minutes. So 1 part is equal to 4 minutes. That means 4 part is equal to 4 into 4, 16 minutes. And 3 part is equal to 3 into 4, 12 minutes. So distance is equal to speed into time. Speed is equal to, if you take speed as 3 km per hour, then 3 km per hour into time response respective to 3 parts is equal to 4 parts. That is 4 part is equal to 16 minutes. 16 minutes, this is in hour, kilometer per hour. So we have to divide 16 minutes with 60. Then it will be in hour. So 3 into 20 is equal to 60. 16 by 20 is equal to 4 into 4, 16. 4 into 5, 20. So 4 by 5 kilometer is the distance. So option B is your answer. Next is question number 3. Two men start together to walk a certain distance, one at 4 km per hour and another at 3 km per hour. The former arrives half an hour before the latter. Find the distance in kilometer. Here we have to find out the distance. And two men walk certain distance, that means they walk same distance. So distance is common here, that means distance is constant. So we have to find out speed and time ratio. Speed will be inversely proportional to time when distance is constant. So speed ratio here, one walk at 4 km per hour and another walk at 3 km per hour. Then time ratio will be inverse of speed, that is 3 by 4. Here former arrives half an hour before the latter. That means difference between both of them is half an hour. Here, but the question says half an hour, but here you can see difference between 3 part and 4 part is 1 part. So 1 part is equal to half hour. Question says half hour and here it says 1 part. So 1 part is equal to half hour. That means 4 part will be 4 into 1 by 2 is equal to 2 hour. 4 part is equal to 2 hour. So distance is equal to, if you take 4 hour, you have to take speed as 3 km per hour. So 3 into 3 km per hour into 4 part is equal to 2 hour. So 6 km. If you want to take above ratio, then distance will be 4 into 3 into 1 by 2. That is 6 km. So you can take anything. If you take 3, then you have to take here 4. If you take 4 here, you have to take 3 here. So distance is 6 km. Option A is your answer. Next is question number 4. A and B start at the same time with speed of 40 km per hour and 50 km per hour respectively. If in covering the journey, A takes 15 minutes longer than B, the total distance of the journey is. Same thing. Here they are covering the same distance. So distance is constant. That means speed ratio is equal to 40 by 50. That is 4 by 5. Then time ratio will be reverse of this. That is 5 by 4. Here A takes 15 minutes longer than B means difference between 5 and 4 is 1 part. 1 part is equal to 15 minutes. So 4 part will be 4 into 15, 60 minutes. That means distance is equal to, here if you take 50, you have to take 4. If you take 40, you have to take 5. So I am taking 50 km per hour. 50 km per hour into, don't take the parts here. Here the real speed is 50 km per hour. So 50 km per hour into 4 part is equal to 60 minutes. 60 minutes is equal to 1 hour. So distance is equal to 50 km. So option C is your answer. Next is question number 5. If a man walked to his office 3/4 of his usual ride, he reaches office 1/3 of an hour late than usual. What is his usual time to reach office? So we have to find his usual time. Here, usual rate means usual speed. When a man walks to his office at his original speed, that is at usual speed, he will be on time. But when he uses 3/4 of his usual speed, he will be late by 1/3 hour. That means here distance is common. Distance is constant because he is going to his office in both the cases. That is, first case he is using his usual speed. Second case he is using 3/4 of his usual speed. So we have to take speed ratio here. Speed ratio is usual speed. If we take usual speed as S, that means 3/4 of usual speed is 3/4 S. That means S cancel. Speed ratio is 3/4 itself. So time ratio will be reverse of speed ratio because distance is constant here. So 4/3. Here difference between 4 and 3 is 1 part. And 1 part is 1/3 hour because he reaches his office 1/3 of an hour later than usual. So 1/3 hour is 1 part. That means 3 part is equal to 3 into 1/3 hour. That is 1 hour. Here you can see this is usual speed. That means this will be usual time. So usual time is equal to 1 hour. Option D is your answer. Next is question number 6. Neeraj, walking at a speed of 20 km per hour, reaches his college 10 minutes late. Next time he increases his speed by 5 km per hour, but finds that he is still late by 4 minutes. What is the distance of his college from his house? So we have to find out the distance between college and house. Here distance is constant because first time he walked at 20 km per hour. Second time he walked at 25 km per hour. So he is walking to his college from his house. So distance is common here. So we have to find out speed ratio and time ratio. Here speed is first time he walked at 20 km per hour. Second time he increases speed by 5 km. That means 20 plus 5, 25 km per hour. So when you take the ratio, 5 5s are 25, 5 4s are 20. So 4/5 is the speed ratio. That means time ratio is reverse of this speed ratio because distance is constant. So this is 5/4. And difference between 5 parts and 1 part, 4 parts is 1 part. And here you can see when he travel at 20 km per hour, he will be late by 10 minutes. When he travels at 25 km per hour, he will be late by 4 minutes. So difference between 4 and 10 and 4 is equal to 6 minutes. So that is 1 part is equal to 6 minutes here. That means 4 part is equal to 4 into 6 is equal to 24 minutes. So distance is equal to here if you take 25 km per hour, then if you take 25 km per hour, then you should take 4 parts. If you take 20 km per hour, then you should take 5 parts. So here I am taking 25 km per hour. That means 4 parts is equal to 24 minutes. 24 minutes means 4 by 60 hour. Because this is 25 km per hour. So you have to convert minute to hour. That is 24/60. So 12 5s are 60. 12 into 2, 24. 5 5s are 24. 5 into 2, 10. So 10 km is the distance. Option C is your answer. Next is question number 7. A thief is noticed by a policeman from a distance of 200 meters. The thief starts running and the policeman chases him. The thief and policeman run at the rate of 10 km and 11 km per hour respectively. Find the distance traveled by the thief before being caught. So, if this is police, this is thief. This police notices this thief at a distance of 200 meters. When the police notices this thief starts running and the police start chases him. Here, thief speed is 10 km per hour and police speed is 11 km per hour. There is a distance between police and thief. So, speed of police must be greater than speed of thief. Then only police can catch this thief. So, find the distance traveled by thief before being caught. So, this thief will travel a distance. And at a point X, I will take this point as X, this police will catch this thief. That means this thief will travel a distance D. So, police will travel distance D plus 200. So, distance traveled by thief is D and distance traveled by police is D plus 200 meter. Here you can see both distance and speed are varying. That means time is constant here. Time is constant here. Whenever time is constant, distance is directly proportional to speed. Here you can see time taken by the thief to reach this point X is same as time taken by the police to reach this point X. That's why police catch this thief at a point X. So here time taken by thief is same as time taken by police. That is why time is constant here. So whenever time is constant, distance taken by police divided by distance taken by time is same as speed of police divided by speed of thief. Here you already know speed of police is 11 km per hour and speed of thief is 10 km per hour. That means distance taken by police divided by distance taken by thief is same as 11 by 10. Here difference between 11 part and 10 part is 1 part. And difference between distance taken by police and distance taken by thief is 200 meter. Because distance taken by thief is D and distance taken by police is D plus 200. So the difference is 200 meter. Here you can see 1 part is same as 200 meter. So distance traveled by thief is 10 parts. So 10 part is equal to 200 into 10. That is 2000 meter. Because 1 part is equal to 200 meter. So distance traveled by thief is equal to 10 parts. Distance traveled by police is 11 parts. So your answer is option A, 2 km. 2000 meter is 2 km. So distance traveled by thief is 2000 meter. So this is 2000 meter. That means this thief will travel a distance 2000 meter and the police will travel 2.2 km. Here, before being caught, thief will travel 2000 meter. Next is question number 8. Speed of father and his son is 12 km per hour and 15 km per hour. They start from A towards B. His son leaves 39 minutes later than his father and reaches 21 minutes earlier than his father. Find the distance between A and B. So we have to find out the distance here. Here both son and father leaves from A to B. So distance is constant here, common here. Father travels at 12 km per hour and son travels at 15 km per hour. Son leaves 39 minutes later than his father and reaches 21 minutes earlier than his father. So time difference between son and father is 60 minutes, that is 1 hour. If you have doubt, take father leaves at 7 a.m. That means son leaves 39 minutes later than his father. So son leaves at 7:39 a.m. If father reaches at 9 a.m., son will reaches 21 minutes earlier than his father. That is, he will reach us 8:39 a.m. Here, time taken by father is 2 hours and time taken by son is 1 hour. So, time difference is 2 minus 1, 1 hour. Here, take the speed ratio because distance is constant here. So, speed ratio is 12 by 15. 12 km per hour and 15 km per hour. 3 4s are 12, 3 5s are 15. So, speed ratio is 4 by 5. Here distance is constant, then time ratio will be 5 by 5. Reverse of speed ratio, that is 5 by 4. Here difference between 5 parts and 4 parts is 1 part. And 1 part is equal to time difference between father and son, that is 1 hour. If 1 part is 1 hour, 4 part is 4 hour and 5 part is 5 hour. That means distance is equal to, I will take speed of son and time taken by son. So 15 into 4 hour, that is 60 kilometer is the answer. If you want to take time taken by father and speed of father, then time is same, distance is same as 12 into 5 hour, that is 60. Option A is your answer. Next is question number 9. Siddharth goes by bike to pick up his girlfriend every day from college and then drops her at her house. College timings are till 5 p.m. daily, but today college was till 4 p.m. His girlfriend, not finding Siddharth at college gate, start walking towards her house. Siddharth, unaware of this fact, leaves his house as usual. Meet his girlfriend on bar, picks her up and drops her at her house. At night, Siddharth realizes that he had saved 40 minutes that day. What is the ratio of speed of Siddharth to that his girlfriend? Both of them live in the same building. If this is college, this is house. College leaves every day at 5 p.m. Siddharth came from his house to this college and picked his girlfriend at 5 p.m. Then drop her back at her house. So this is his path every day. But today, college leaves at 4 p.m. Siddharth doesn't know that. So his girlfriend started walking to her house. Siddharth started his journey at usual time. Then he met his girlfriend on his way. Then he picked her from this meeting point and dropped her back to her house. So today Siddharth saved 40 minutes because he traveled less distance today. That means from college to meeting point and meeting point to college, he takes 40 minutes to complete this journey. That means from meeting point to college, he takes 20 minutes. From college to meeting point, he takes 20 minutes. He arrived college usually at 5 p.m. That means at meeting point, he arrive at 4:40 p.m. because he takes 20 minutes to complete this path. That is college to meeting point, he takes 20 minutes. Then if he arrive college at 5 p.m., then he arrive this meeting point at 4:40 p.m. If he arrive this meeting point at 4:40 p.m., that means his girlfriend walked for 40 minutes that day. Today, his girlfriend walked for 40 minutes because college leaves at 4 p.m. Then she walked for 4:40 p.m. That is, she walked 40 minutes today. That means time ratio for this path, that is college to meeting point, time ratio, if you take the time ratio for Siddharth and his girlfriend, time ratio for Siddharth to time ratio to girlfriend is equal to 20:40. Siddharth take 20 minutes to complete the path and girlfriend take 40 minutes to complete this path. That means 20:40 is equal to 1:2. So if the time ratio is 1:2, speed ratio will be reverse of that because distance is constant. That means speed will be reverse of time ratio. So speed ratio is 2:1. So option A is your answer. Next is question number 10. The distance between 2 points A, B equal to 110 km. Manoj start running from A at a speed of 60 km per hour and Ravi start running from B at a speed of 40 km per hour at the same time. They meet at a point X somewhere on the line AB. What is the ratio of AX to BX? Here they are asking us about distance ratio, that is distance of AX to BX. Here they meet, both of them meet at a point X. That is, they have a meeting point. That means time is constant here. Time is constant here. Whenever you have time as constant, distance will be directly proportional to speed. So if you want distance ratio, that will be equal to speed ratio. So if you take the speed ratio, that will be your answer. So here speed ratio is 60:40 because Manoj's speed is 60 and Ravi's speed is 40. So 60:40 is your speed ratio. That means 20 into 3, 60, 20 into 2, 40. So your answer is distance of AX to BX is same as speed ratio is equal to 3:2. So your answer is option A. If you want an explanation, this is AB and distance between them is 110 km. Manoj start running from A towards B at a speed of 60 km per hour and Ravi start running from B towards A at a speed of 40 km per hour. They will meet at a point X. We don't know where it on AB. So that means they have a meeting point. That means time taken by Manoj to reach X is same as time taken by Ravi to reach X. Whenever you have meeting point, that means time is constant because here time taken by Manoj to reach X is same as time taken by Ravi to reach X. So here time is constant means take the speed ratio, that is 60/40. So this is your answer. Speed ratio is 60/40. That will be same as d of dAx by dBx. That is, here distance covered by Ax and Bx will be same as speed of Manoj to speed of Ravi. So your answer is option A. Next is question number 11. In a race of 100 meter, A gives a start of 10 meter to B. Despite this, A wins the race by 20 meter. What is the ratio of speed of A and B? Here, there is a race of 100 meter. Race of 100 meter. This is starting point and this is finishing point. It's a 100 meter race. Here A gives a start of 10 meter to B means when B is 10 meter, when B finishes 10 meter, A starts the game. A gives a start of 10 meter to B. That is, A is giving 10 meter to B means when B finishes 10 meter, A starts the game. Same way, A wins the race by 20 meter. That means when A reaches the finishing point, B is still 20 meter behind A. B is still 20 meter behind A. A wins the race by 20 meter means when A reaches the finishing point, when A covers the 100 meter, B is still 20 meter behind A. That is, B is at 80 meter. Okay. That means here you can see when A finishes 100 meter, B finishes 80 meter. So distance is not constant because when A finishes 100, B only finishes 80. So even though it is a 100 meter race, when A finishes 100, B finishes 80. So distance is not constant. Also speed is also varying because when A reaches 100, B reaches 80. So distance is, speed and distance are not constant here. Only time is constant. How? Here you can see when B reaches here, A start the game. When B reaches this point, A start the game. That means time to reach from this point to this point. Time for B to reach this point to this point is same as time for A to finish this 100 meter. Time for B to finish 70 is same as time for A to finish 100 meter. That is, time for A to finish 100 is same as time for B to finish 70 meter. Here, when B reaches here, A start from here. When B reaches here, A finishes here. That means time taken for this distance is same as time taken for this distance. So here time is constant. That means distance is directly proportional to speed. So if you take the distance ratio, you will get the speed ratio. Here question is asking about speed of A and B. That means speed of A and B is equal to same as speed of A by B is same as distance covered by A and B. That means distance covered by A and B is 100 divided by 70. So 10 is to 7 is your answer. Option A is your answer. Next is question number 12. There are two persons A and B with a speed of 20 meter per second and 10 meter per second respectively. And length of the circular track is 1000 meter. When will they meet for the first time anywhere on the track if they are running in opposite direction? Here we have a circular track of 1000 meter. And we have two people A and B running in opposite direction. That means if A runs anti-clockwise direction, B will run in clockwise direction. And we have to find out time for their first meet. If this is the point where they meet, we have to find out time for their first meet. You know time is equal to distance by speed. But here it is length of the circular track and speed will become relative speed because we have to find out the time for meeting time of two people running in opposite direction. So whenever you have question asking us about time for meet, just use the relative speed instead of speed. So here length is equal to 1000 meter and relative speed is equal to speed of A is equal to 20 meter per second and speed of B is equal to 10 meter per second. So 20 plus 30 is relative speed because they are running in opposite direction. That means 1000 divided by 30 is same as 33.33 seconds. So option B is your answer. Here relative speed of two people running in opposite direction is the addition of their speed. Relative speed of two people running in same direction is the subtraction of their speeds. So option B is your answer. Next is question number 13. In the above question, when will they meet for the first time at the starting point? So meeting at starting point is same as LCM of length of circular track by speed of first person and length of circular track by speed of second person. That means here 1000 by speed of first person is equal to 20 and 1000 by speed of second person is equal to 10. That means LCM of 1000 by 20. This is 50 and this is 100. LCM of 50 and 100 is 100. So option D is your answer. Next is question number 14. A man cycles with a speed of 10 km per hour and reaches his office at 1 p.m. However, when he cycles with a speed of 15 km per hour, he reaches his office at 11 a.m. At what speed should he cycle so that he reaches his office at 12 noon? Here distance is constant because he is going to his office. At 10 km per hour, he will reach his office at 1 p.m. and at 15 km per hour, he will reach his office at 11 a.m. And at what speed he will reach his office at 12 p.m. So we need to find out the speed. Here distance in all these three cases, he is going to his home. Distance is constant. So that means speed is inversely proportional to time. So whenever distance is constant, find the speed ratio and time ratio. Speed ratio here is 10 by 15. 10 by 15. That means 2 into 5 into 2, 10, 5 into 3, 15. So 2 by 3 is speed ratio. That means time ratio is inverse of speed ratio. That is 3 by 2. Here difference between 3 part and 2 part is 1 part. And that 1 part is equal to 2 hours. Because here difference between 1 p.m. and 11 a.m. is 2 hours. 1 p.m. and 11 a.m. difference is 2 hours. So if 1 part is 2 hours, 2 part will be 4 hours and 3 part will be 6 hours. That means he takes to reach 1 p.m. To reach at 1 p.m. he takes 6 hours. To reach at 11 a.m. he takes 4 hours. Here distance is equal to speed into time. I will take 15 as the speed. Then time respective to this 15 is 2 part. That is 4 hours. So 15 into 4 is equal to 60 kilometer is the distance. That means speed needed to reach at 12 p.m. is speed is equal to distance by time duration. Here distance is equal to 60 and time duration is here with a 4 hour duration he will reach 11 a.m. So with 5 hour duration he will reach 12 p.m. because if you reach at 11 a.m. with 4 hour duration, that means you are leaving your home at 7 a.m. The same way, to reach at 12 p.m. you need 5 hour duration. So 60 by 5 is equal to 12 kilometer per hour. So option C is your answer. Next is question number 15. A bird is sitting on top of a car. It sees another car approaching it at a distance of 12 kilometer. The speed of the two cars is 60 km per hour each. The bird starts flying from the first car and moves towards second car, reaches the second car and comes back to the first car and so on till the two cars crash. If the speed at which the bird flies is 120 km per hour, then the total distance traveled by the bird before the crash is. Here, a bird is sitting on top of a car. That means if this is a car, a bird is sitting on top of it. And it says another car approaching at a distance of 12 km. So, at a distance of 12 km, it says another car approaching it. So, another car approaching it at a distance of 12 km. Distance between these two cars is 12 km. And the speed of two cars is 60 km hour each. That means this is 60 km per hour and traveling in this direction. This is also 60 km per hour and traveling in the opposite direction. That means these two will facing each other. The bird starts flying from the first car and moves towards the second car, reaches the second car and comes back to the first car and so on till the two cars crash. That means these two cars will crash. Till that time this bird will fly towards each other. That is, when this bird fly to the second car, again it will go to the first car. Again it will go to the second car. Again it will comes to the first car. Till these two cars will collide each other. That means if this is first car, this bird is there and this bird will goes to the second car. By the time the bird fly, this car will move here. Second car will move here. Then bird will come here. Then again this bird will go back to the first car. That means this car will come forward. Again this bird will go to the second car. By the time the car will move forward, again it goes back. So till The bird will fly till these two cars have a crash. That is, meeting point of the two cars is the time traveled by the bird. That is, time traveled by the bird is equal to meeting point of the, that is collision point of the two cars, crash point of the two cars. So, here the bird will fly till these cars two have a crash. That means time of meet of these two cars will be same as time of bird fly. Time of bird flying. Here, this bird will fly till these cars two have a crash. So, here time of meet is equal to same as distance traveled divided by relative speed. Here, both cars are at equal speed and running towards each other. That means running in opposite direction. So, here this is 12 km and both cars have equal speed. That means the two cars will have a collision at the middle point. That is at 6 km. These two cars will collide each other, hit each other. Here relative speed is equal to 60 plus 60 because both are facing each other, opposite. Both are facing opposite to each other. So that means relative speed will be 120 km per hour. So here time of meet will be distance is equal to 12 km and relative speed is equal to 120. That means 1 by 10 hour. So time of mate is equal to time of bird is equal to 1 by 10 hour. So your answer is total distance traveled by the bird. Total distance traveled by the bird. Distance traveled by the bird. So that is equal to the speed of the bird into time of travel of bird. Here speed of bird is 120 and time of bird is 1 by 10. That means 12 km is the distance covered by the bird. Option B is your answer. Here if you want to find out time to meet without this relative speed aspect, try to find out time taken by any of this car to reach this midpoint. That is time taken by this car to cover this 6 km distance. That is time is equal to time to meet is equal to distance divided by speed. Distance is equal to 6 and speed of car is equal to 60 km. So 6 by 60 is equal to 1 by 10 hour. So this is same as time to meet. Time of crash. So you can find out the time of crash using this method also. If you don't know the relative speed aspect, you can use this method as well. So that's all for today. Thank you for watching. If you like this content, please subscribe, share and like.